This video is going to have a look at fractional distillation. By the end of the video you'll know what fractional distillation is, why it's useful, and what all the different parts are. To begin with, we have crude oil. Now crude oil is a mixture of hydrocarbons. What that means is there's lots of different types of hydrocarbons in there, different sizes, different shapes, and not chemically bonded together, which means they can be separated, and they're separated by boiling point. So what is crude oil? Crude oil is where animals and plants die, and then they get buried by lots of different types of rock. And over millions of years, the pressure from the rock creates crude oil out of these fossils. So once that crude oil is there, it's ready to be mined out of the ground. Once we do that, we get this mixture. Now, we have some gases in there, we have some really short-chained hydrocarbons which ignite and set on fire really easily, and we have some really long-chained ones which are used in tarmacking roads. Now obviously, all these things combined, you couldn't put that into your car. If you did, it would stop working. So there has to be a way to separate them, and that's what fractional distillation means. Distillation, separating by boiling point, and the fractional part means different fractions, different sections. And I'll show you how that works now. So we start off with this, which is a fractionating column. We put our crude oil, our mixture of all the different hydrocarbons, in here. It goes into there. Now it's vaporized in this chamber here, so with lots of heat we turn the crude oil into a gas. That's at about 400 degrees C. Now straight away your bitumen, your really thick stuff, won't vaporize. This will come out through here, remain as a liquid, and be collected at the bottom. The rest of it, however, because it's a gas, will start to move up the fractionating column. So the first thing to note, that it's really hot at the bottom and cool at the top. Now as this gas starts to go up there, different fractions will have different boiling points, different points which they turn from a gas to a liquid or a liquid to a gas. So when it gets to this first point here, some of the gases will start to condense, turn back into a liquid. Others will continue up through here. The first thing that's filtered off is fuel oil, and this is at about 340 degrees. Then the next one that's filtered off is diesel, and that's at about 250 degrees. So once that condenses, the rest of it will continue up, and your next one you get is kerosene, and that is at about 180 degrees. The rest of it continues up again, and the next bit that comes off is called naphtha, which I'll put in brackets because you don't really need to know that for the exam. And then final, up here, you get your petrol, which is about 40 degrees. Any gases, like the stuff that you use in Bunsen burners and cookers, will come out the top, still as a gas. So, as you come up the fractionating column, it gets cooler. The chains become smaller. It becomes less viscous, which means runny. And more flammable. So for example, up here, this might only have a chain of 3 carbons, 1, 2, 3, whereas down at the bottom it might have about 40 carbons for bitumen. Bitumen is really thick, so highly viscous, and because it's used in the tarmac on the roads, you can quite easily tell that it doesn't set on fire very easily, so it doesn't ignite. Whereas at the top, your gases, short chains, and ignites very easily. Now for the exam, you'll need to know each of these fractions, what they're used for, and why. So our gases then, which are the shortest chain, easiest to ignite, and the most difficult to store, because it is a gas, they are used for cooking and heating. Because they give out a lot of energy, you don't have to put much energy in to get them to light. So petrol is a liquid, so it's easy to store, easily ignited, and gives out lots of energy, so therefore it's used as a fuel for cars. Naphtha, as I said, you don't really need to know, but if you did want to, it's a lighter fluid and it's used in the chemical industry to make other chemicals. So kerosene, it's got a slightly longer chain length but still gives out a lot of energy, therefore it's used as a jet fuel, so fuel in aeroplanes. Diesel is used as a fuel in lorries, trains and some cars, but obviously not all of them, most of them are petrol. Fuel oil is used for a fuel in ships and power stations. Be very careful here. In a lot of exams I've seen people put fuel oil is used for cars. Just because it's got the word fuel in it doesn't mean that it's used for that. It's used for ships and power stations. And then bitumen, which is the longest chains, the most viscous and are the hardest to ignite. They're used in your road surfacing and on your roofs to waterproof them. And that should be everything you need to know about this.